Welcome to Get Your FRQ On. This question is from the 2002 exam. It's question 3, and it is calculator active. In the question stem, we're given that an object is moving along the x-axis, and that at time t equals 0, the position of the object is at 2. And we are also given that for non-negative values of t, the velocity of the object is given by a trigonometric function. Part A, we are asked to determine the acceleration of the object at time t equals 4. We are given the velocity of the object as a function, v of t is sine of pi thirds of t. The acceleration at time t would just be the value of v prime of 4. So if we calculate v prime, using the chain rule, we get pi thirds times cosine pi thirds t. To find the acceleration at time t equals 4, we just substitute 4 in for t. V prime of 4 is pi thirds times the cosine of pi thirds, which turns out to be negative pi sixths. Right? Since this is a calculator active question, you could also use your calculator to determine the acceleration at time t equals 4. It doesn't really require it here. This is pretty basic computation using trigonometric values, which should be on the unit circle. But if you do use your calculator for this, make sure you clearly demonstrate what it is you are asking your calculator to do. Typically, if you don't make it clear what math or calculus you're making your calculator do, you will fail to earn some points on a free response question. So at the very least, declare that you're finding v prime of 4, that you know what function requires you to find v prime of 4, and then provide the answer from the calculator. Which is about negative 0.524 or negative 0.523, depending on whether you're rounding or truncating. In part B of this question, we are asked to determine whether both or either, really, of the following statements are correct. The first statement is that for t between 3 and 4.5, the velocity of the object is decreasing. Statement 2 is that for t between 3 and 4.5, the speed of the object is increasing, and we have to determine whether either of these statements is true, and if so, which ones. All right, well, the velocity of the object will be decreasing if v prime of t is less than 0 on the interval from t equals 3 to 4.5. Well, that's easy enough to find out. V prime of t, we found a formula for that in the first part of this question. V prime of t is pi thirds times cosine of pi thirds t, which, if t is between 3 and 4.5, this is negative for all such values of t. So, the first statement, the velocity of the object is decreasing for t between 3 and 4.5, does seem to be true. The velocity is negative, or the rate of change of the velocity is negative, the acceleration is negative on that interval for all values of t, so that would be true. The second statement, the speed will be increasing for t between 3 and 4.5 if v of t and a of t have the same sign. So if they're both positive, speed is increasing. If they're both negative, speed is increasing. But if they have different signs, speed will be decreasing. Well, the velocity function is just sine of pi thirds t, which, if t is between 3 and 4.5, is also negative for all such values of t. So, combining that with what we just figured out for part 1, that the acceleration is always negative for t between 3 and 4.5, we now know that the velocity is also always negative between 3 and 4.5. So acceleration and velocity have the same sign for all values of t on this interval. So the second statement, the speed of the object is increasing, is also true. So both of those statements are actually correct. In part C, we are asked to find the total distance traveled for the object between t equals 0 and t equals 4 seconds. Total distance traveled by an object is an application of the fundamental theorem of calculus. We just have to be careful to take the absolute value of our velocity function. Right? So the total distance traveled is the value of this integral from 0 to 4 of absolute value of v of t dt. But since this is a calculator active question, You can set this up and do this on your calculator rather than try to figure out by hand if there's anywhere where v of t changes sign and then have to split it up into two separate integrals. As long as you write down what calculus you are asking your calculator to do, you should be fine using your calculator to do this. The integral from 0 to 4 of absolute value of v of t dt is the integral from 0 to 4 of the absolute value of sine pi thirds t dt, and that turns out to be about 2.387. In part D, we are asked to determine the position of the object at t equals 4. Position of the object will require use of the initial condition that x of 0 is equal to 2, but this is also a fundamental theorem of calculus question. The position at t equals 4 can be found using definite integration. X of 4 is just x of 0 plus that integral, only without the absolute value. So we have x of 4 equals x of 0 plus the integral from 0 to 4 of v of t dt. We're given that x of 0 is 2, so we can substitute that in. We know that v of t is sine of pi thirds t. Since this is a calculator active question, we can use our calculator to find the actual value of this integral. This can probably be done by hand just as easily, but it is calculator active, so there's no need to do it by hand. One thing you definitely don't want to have happen is to try to get cute by doing the calculus by hand and then accidentally throw in a negative sign when you don't want one, or omit one when you don't want one, as would be the case in this one if you forget the negative sign here. So if it is calculator active, just play it safe, use the calculator to do this. If we ask our calculator to do this calculus for us, the position of the particle is 3.432 along the x-axis.